Okay, let's just dive right into this. Welcome to this explainer where we're going to explore a completely different approach to complex system design. You see, when you're programming a massive system or, say, trying to give an AI a set of targeted programming goals, it's just incredibly difficult to list all the rules and rails for every single edge case. The traditional fallback? A sprawling giant constraint.md file. But today, we're looking at a pretty fascinating alternative. We're talking about replacing those massive, impossible-to-read text files with, well, imaginary people. We're going to see how using these avatars as constraints can radically improve our code, keep systems lean, and even properly guide an AI. But to understand this solution, we kind of have to understand the problem first. When you're programming massive systems, think file systems, engineers often try to satisfy every imaginable workload all at once. Like you want it to be blazing fast for small files, fast for large files, perfect for random writes, perfect for sequential reads, the whole shebang. But attempting to be literally everything for everyone, it turns codebases into these bloated, endless debates instead of actual functional tools. It literally becomes a theological debate encoded right into the source code. The project just balloons, and eventually nobody truly understands the core mission anymore. Section 1, the edge case problem. So traditional specs often devolve into these giant, sprawling parameter jungles. Engineers get totally detached from reality and start, worshiping synthetic metrics. They're trying to optimize for a queue depth of 7 or a random write ratio of exactly 13%. Basically, they're trying to build systems to survive synthetic torture. But compare that to human reality, right? Picture a 14-hour day in Alaska shooting grizzlies. Real operators out in the field, they don't care about some PhD benchmark paper. They just care that their data is safe after a grueling day out in the freezing cold.
Section 2, meet Jay and Chris.
To solve this exact disconnect, the developers of the Slim64FS file system completely threw out those abstract benchmark matrices. Instead, they replaced them with two fake humans with highly specific needs. First up is Jay. He's a wildlife photographer. He's out in the field, shooting huge raw bursts onto removable media. He deletes, he creates, he fills disks. He is essentially the patron saint of turn pressure. His core need? Sustained correctness. Then we have Chris. Chris is an AK videographer. Now, he isn't spraying little files around, he's pushing sustained write pressure. Chris is the guy who accidentally drops his camera on the pavement while the red recording light is still blinking. Yeah, Chris is the patron saint of durability honesty. If the file system says the footage is saved, it absolutely better be there. Section 3, the power of avatars. Now this brings us to a really fantastic concept, TARDIS constraints. The developers jokingly called Jay and Chris TARDIS constraints because, just like the time machine from Doctor Who, they're way bigger on the inside than they appear on the outside. You have this simple persona, a photographer or a videographer, but packed inside that persona is a compressed, gigantic operational universe. I mean, just by thinking of Chris, you instantly reveal a whole suite of engineering decisions that this avatar would either demand or totally reject. It's an incredibly mentally portable constraint. And this brilliantly illustrates the hidden power of these avatars. They create crucial operational rails. Think about it. In systems engineering, every feature you don't build is often way more important than the ones you do. If someone proposes some whiz-bang new feature, Jay and Chris constantly force the question, does this actually improve operational trust for our avatars? And if the answer is no, well, the avatars quietly veto it. Because it's tied to a human narrative, it's a much tighter constraint than any generic documentation. It instantly narrows the design space and firmly prevents that dangerous be everything for everyone trap from becoming a feature circus. Section 4, avatars versus endless documentation. So, why is this so much better? It all comes down to a recursive cycle. When you use avatars, they dramatically narrow the operational universe. Remember, Jay needs churn predictability, and Chris needs durability truth. That right there is a tight, understandable design space. Because the avatars are so specific, these constraints aggressively collapse code paths. You simply don't write the unnecessary code. And collapsed code paths lower your overall lines of code, or LOC. Lower LOC drastically increases the auditability of the system. And finally, high auditability increases deep, fundamental trust. The whole system just recursively reinforces itself. Let me give you a real-world example of how this practically influences engineering on the fly. So, during a tricky recovery development phase, the team had this dilemma. Do we aggressively reclaim uncertain data space, or do we conservatively defer cleanup? Now, a benchmark-oriented brain says, clean up aggressively, keep those stats high. But the avatar-oriented brain steps back and asks a much simpler question. Would Chris prefer leaked space or corrupted footage? Suddenly, the answer is instantly obvious, right? Leaked space is annoying, for sure, but corrupted footage? That ends careers. So, deferred cleanup wins instantly. The avatar quietly carried that entire operational philosophy right inside it. Section 5. Guiding AI with Stories. This is where it gets really interesting for the future. As we increasingly use AI to program and audit complex systems, we really have to realize that AI, much like human operators, processes intent incredibly well through stories. A massive constraint.md file full of abstract rules, that is super hard to perfectly balance and prioritize. But telling an AI to optimize for a camera drop simulation, that instantly communicates way more contextual intent than 3 pages of abstract crash semantics ever could. Clarity is leverage here. Story-backed constraints are self-revealing, and honestly, they're vastly closer to keeping the correct targeted programming goals for an AI than a traditional sprawling constraints file. So imagine an AI assistant actually writing code for your system. Instead of it just referencing a giant textbook of rules, it's programmed with the targeted goal of serving these avatars. It can pause, self-reflect, and ask, does this new whiz-bang feature actually help Jay or Chris? And here's the magic of this whole approach. If whatever whiz-bang new item is to be added cannot be explicitly proven to help Jay or Chris, it is simply left out. Boom. It is a profoundly tighter, much more robust constraint system than standard documentation, simply because it intuitively filters out useless features based on tangible human needs. Which brings us to our final thought for this explainer. As we build increasingly complex systems, whether we're using human hands or guiding an AI, we have to look at our rails and ask ourselves this fundamental question. Are you building to survive synthetic torture? Or are you building to survive reality? Are your constraints designed for theoretical perfection on a chart, or are they designed to protect the user who drops their camera on actual pavement while the right light is still blinking? By replacing endless documentation with avatars, we anchor our technology back where it belongs, in the messy real world. Definitely something to think about the next time you sit down to design a system.